Whenever I encounter this case, the first thing I have to do is to replace my 0 in the first column with a very small value, which is an epsilon. So I will just have E to replace my 0. So for computing the s to power 1 row, I have to use the immediate first two rows, which is s to power 2 and s to power 3. So again, I will just have epsilon times 2. I will have 2 epsilon minus 2 times 1, which is just 2, all over epsilon. So I will just have 2 epsilon minus 2 over epsilon. So for the next element, I will just have epsilon times 0, which is 0, minus 2 times 0 over epsilon. So I will just have 0 here, and then I will have 0 because I've exhausted the columns. So moving to the final row, I will use the elements in s to power 1 and s to power 2 for the computation, and this is my pivot. So for the first component of s to power 0, I will have 2 epsilon minus 2 over epsilon times 1. Then I will have minus epsilon times 0 all over the pivot, which is this one, 2 epsilon minus 2 all over epsilon. So I will just have 1. So it means I will have 1 here. Moving to the next computation, that is using this column and the third column, I will have this value times 0 will be 0, minus epsilon times 0 will be 0 over this pivot. So I will have 0. I have exhausted my columns, so I will have 0 again. So the next step in this case is to reverse the substitution we did earlier on. That means to apply limit as epsilon approaches a very small number. So our first column will turn into 1, 2. Our epsilon will approach that small number, and applying the limit to this value, I will have 2 minus infinity, because 2 over a very small number will be minus infinity, and I will have 2 minus infinity will be minus infinity, and then I will have 1. So this is my new first column. So my remark will be, since I have 2 change in sign in the first column, it indicates that I have 2 force in the right hand side of the S-plane and my system is not stable.